Today we're going to be doing jump game. You're given an integer array nums. You're initially positioned at the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, and false otherwise. So let's go through an example. So the objective is we want to see if we can reach the last index by jumping through the list, and the length of our jumps is determined by the value at an index itself. So for example here, the maximum we can jump is 2 indices, so that would be 3 and 1. But because we ran to 3, the highest we can jump here would be 3 indices, so it would allow us to reach 4. And so that's why we return true in this case. For the second example, we see that we have the case here where we have 3, which would allow us to jump to 0. We have 2, which also jumps us to 0, and 1 which also allows us to jump to 0. However, at 0 we cannot jump any further, so we cannot reach the last index, so therefore we return false here. So the approach here would be, essentially we keep track of the furthest index we can jump to, and we loop through the nums list, updating this furthest variable, and whenever we reach an index that is not reachable or is out of the bounds of our furthest index, we return false because we have exceeded our limit. But however, if we reach the last index, it implies that the last index was within the bounds, so therefore we can return true. So the implementation for this would be, we store a variable called furthest index, which is initialized to 0. We loop through all the nums, and at every number we update the furthest index to track the furthest we can travel. So furthest index is equal to the maximum of furthest index, and the furthest we could travel would be the current index plus num. So that would be the furthest we can travel, but we want to make sure before we reach this step that we check that our current index, IDX, is reachable. So if it's larger than our furthest index, that would mean that we cannot travel to this index, so we return false. Once all this done, and we don't return false in the middle of the program, it means that we can reach the end, so we return true. So let's run this code. Okay, let's submit it. Okay, so the space complexity is O of 1 because we're only keeping track of an integer, which is constant space. The time complexity is O of n because we're looping through nums list. And yeah.